Did it simplify? Did it streamline the process, for example? Okay. Did I come up with a better solution? I'm going to give you some examples in a minute, okay, in terms of what that really means, in terms of understanding customer requirements and understanding supplier capabilities and meeting on-time delivery and reducing the cost. Oh my gosh. Oh, look at that. Okay, thank you. Okay, so with that, good question. We'll come back to that. If you give me a half an hour, okay? I will too. So, 90% of organizations agree. One, deploying AI is a struggle. Why? Why is AI implementation a struggle? Why is leaning an organization a struggle? Why is applying Six Sigma principles a struggle? Come on. Complexity overlaying complexity. Brilliant. Brilliant. Okay? Keep going. Come on. Tell me what she said. Depending upon the model. Yeah. If the model's wrong, automating a mess is still a mess, isn't it? Okay? That's a good comment from a dear friend of mine. Come on. Data systems are not easy to work with even today, okay? And there's heterogeneity, there's data integrity issues, there's lots of other issues. Come on.
From the users?
Come on.
Resistance of change from the users?
I hate change. That's what you're going to get, isn't it? Okay? What do you mean you're going to replace me with a robot? What do you mean that there's an AI algorithm to replace the scheduling organization within your company? What do you mean that I am being replaced by a decision support system? They're going to push back, aren't they? Now, I will offer to you the following. Our beloved friends in computer science don't know squat about how to make change happen. Okay? You industrial engineers better know how to make change happen, or I'm going to fire you. Clear? That's your job description. Make change happen. Successfully make change happen. Okay, so with that, whoop, it lasted for one chart, Ali. Okay. Not quite what I had in mind. This doesn't work either. Okay. That went backwards. Let's try that. Thank you. Okay. So let me bring you up to date. We're in the 4th generation of manufacturing. Industry 4.0. Have you discussed Industry 4.0? Have you been exposed to Industry 4.0 yet? Okay, so let me expose you to Industry 4.0. Industry 1.0. 1.0 was mechanical production, 1784, railroads and steam power, okay? We called it Industry 1.0. Industry 2.0 then said, lo and behold, if Henry Ford can mass produce that Model T and Model A, you can have standard product being produced on an assembly line, and I can sell you an automobile for $300. That was his target price. Okay? Which in 1870 was a lot of money. Then we introduced the computer to manufacturing, didn't we? And all of a sudden we had computer-aided design, computer-aided manufacturing. And along came the internet. The internet is only about 35 years old, ladies and gentlemen. Think of it. How in the world did I, in 1975, when I walked into active duty Air Force, communicate with my colleagues in Washington, D.C. I actually had to talk to them on the phone. Unheard of. My goodness, we don't talk to people. We text them, don't we? Or we send them an email, and we have an attachment for all the documents. How do we send a document? Through the mail. How crude. How in the world did we exist? Can you believe it? We actually made airplanes that flew without the internet. Unbelievable. I'm helping General Dynamics down at F-16, down at Fort Worth. We were producing F-16 aircraft in 1976, okay, with 3-spindle 5-axis machine tools, and we were just novices when it came to DNC and CNC, okay? So then along came Industry 4.0. The term was coined in Heidelberg about 15 years ago, okay? And in essence, it says, now that I'm going to take manufacturing to the next level, I'm going to build this bridge to decision support systems that we've never had before. Artificial intelligence, digital twins, automation, robotics, IIoT, et cetera, et cetera, et cetera. Okay, you know the plethora of toys and tools that I'm talking about. Industry 4.0. Now, let me give you examples. When I grew up in northwestern Indiana, there was a machine shop up the hill. So I walked up the hill and learned how to mill apart using a Bridgeport. Yes, Bridgeport. You ever hear of a Bridgeport? Nope. Okay. A Bridgeport is a basic milling machine. The part would go around, and I would put a cutter in there, and I would remove material. Got it? Muy bueno. Okay. And I would do everything. I would do the speed, the feed, the depth of cut, the cutting fluid. I would listen to it. I would watch it. I was totally in charge. Industry 2.0. Then I went to Purdue. And Purdue had NC, CNC, DNC, where the computer controlled the machine tool. My job was to program it, okay? And we developed algorithms to program the machine tool, and we would do the same milling process, but it was computer controlled, better than I could ever do it. 3.0. 4.0. 4.0 then says the following. Now, I take a solid model of the part that I wish to produce. I present that to an AI algorithm. It does all the slicing for me. It may not even do the milling. It may do additive manufacturing and build it up rather than remove the material. I may add the material to it in an additive manufacturing format, okay? And my job now is to watch it if I want to. If and only if I have an interest in it, I just hand it off. 4.0. Clear? Now, I entered 75. My job was to get the aerospace industry of the United States from Industry 2.0 to Industry 3.0. Was there resistance to change? Absolutely. You think walking out on the factory floor at General Dynamics in Fort Worth and telling a machinist that she or he is going to be replaced by a computer, you think I got resistance? Damn straight it did, folks. Okay? Your job is to take us from 3.0 to 4.0. Okay? Clear? Keep going. So, AI for SE, artificial intelligence for system engineering. This is a series of webinars put on by INCOSE, International Council on System Engineering. Got it? Okay. So something new is happening in system engineering. Historically, system engineering has been heavily reliant on human expertise. You bring the knowledge with you, okay? However, with the advent of sophistication, there's been a paradigm shift. AI tools are now augmenting human capabilities. AI for SE, okay? Examples. Focus on quality of data. I'm going to push you to get to at least 4 sigma data quality. I'm going to give you a couple examples in a minute. 4 sigma data quality, minimum. What's 4 sigma? Chop off both tails. Come on, statistical gurus. What's 4 sigma? 99.97? Come on. What's 6 sigma? Less than 3.4 errors per million opportunities for errors. 99.9997% accurate. You got to know that. 4 sigma. 99.97. 99.7, I'm sorry. Okay? Now, you think that's tough? Data integrity of 4 sigma? I'm going to attempt to prove to you in a moment that that is the minimum essential functionality that's required for data to drive the ERP system at Intel. And I'm going to show you the data to back it up in a minute, okay? I want you to think about becoming a data scientist. I don't care what your major is. Industrial engineering, engineering management, whatever you're majoring in. You need to couple that with becoming a data scientist, because for every one of the disciplines that you're going to encounter in your life, I don't care if you become a lawyer. God help you if you become a lawyer. Okay, I have to tell you a story. I'll show you my bias. Okay, there are 3 lawyers standing on top of the Sears Tower in downtown Chicago. Okay, you know Chicago, downtown Chicago, Sears Tower. 3 lawyers standing on top of the Sears Tower. There's a divorce lawyer, a tax lawyer, and a corporate lawyer. Got it? Let me repeat, because this is important. Divorce lawyer, tax lawyer, corporate lawyer. Got it? And they all jump off the Sears Tower at exactly the same instant. Which one lands first? I don't care. Got it? My bias. Legal folks have really not helped us in many instances. You've talked about, Cox, digital Cox. We invented that here at ASU in my labs in about 1987, 1988. We teamed up with Time Warner and Digital Equipment, and we demonstrated bidirectional communication between Boeing out in East Mesa and 2 of their suppliers here in Tempe. We had a meeting with the lawyers of all 3 companies, ASU and the 2 other companies, to figure out how do we divvy up all this potential revenue that's going to come from Cox at home and online. This was 1988, 1989. And the ASU lawyer comes out and tells me, Dan, I got bad news for you. We're a public institution. We cannot hold equity positions in public companies. ASU had to walk away from their revenue portion of online, of the entire digital spectrum. Do I love lawyers? I love lawyers. Okay? Bias. Let me back. Okay. Focus on AI from a people standpoint. That's where you come in. Okay? If you're an industrial engineer, 1 foot in the technical camp, the other foot in the business camp, both of which are focusing on making change happen in the people aspects of it. And it's not trivial. And then finally, from the executive standpoint. So my recommendation to you, and this is what I'm telling all my grandchildren, I don't care whether you might major as a veterinarian or a business major or an AI major, that's what they're majoring in, okay? You got to become a data scientist. And I'll let you figure out what you think that means, okay? So, with that, my synopsis of the front end. 1, get your company to understand how to achieve data integrity. 2, understand the people implication. I just gave a talk, a webinar, had a couple hundred people online about a month ago for AME, talking about the people implications of artificial intelligence. I'll send Ali a copy of the talk. You might find that of interest, okay? What's the value? What's the risk? Is your workforce prepared? Does the leadership understand it? Know how to do conference room pilots, okay. So let's focus on 2 of those topics. Number 1, let's focus on data integrity and workforce implication. Data integrity. Automating a mess is still a mess. Got it? Automating a mess is still a mess. Roger Willis said that. Dear friend of mine, former partner at Accenture, former partner at Ernst & Young, knew what he was talking about. Computer scientists don't understand that yet. And I'm exposing another bias to try and get you motivated to dig into this, okay? So what's it mean? It's approaching dinner time. I know all of you are going to go to McDonald's for dinner tonight. I'm being facetious. 2 all-beef patty special sauce, lettuce, cheese, pickles, onions on a sesame seed bun, a Coke and a fry, 10 items. You get 1 sigma accuracy at McDonald's. What's the probability that you're going to get a good meal? 1 sigma. 1 sigma is 30%. 0.3 to the 10th power is what? That's about 0.000006. No bueno. Agree? 1 sigma, 10 items. 3 sigma. Let's go with 93% accurate for 3 sigma. Okay? 0.93 to the 10th power is 50% of the time. Half the time you're going to get a good meal, half the time you're not. Something's going to be wrong at 3 sigma accuracy. 4 sigma, 99.4%. Now I'm getting down to 1 in 20 meals are bad. Now McDonald's has to make a business decision, don't they? Because if I go up to 5 sigma and 6 sigma quality, the cost of going up, it goes up exponentially. So now, are you willing to go to McDonald's or wherever and 1 meal in 20 has something wrong with it? But if you get better than that, 5 sigma and 6 sigma, the cost is going to go up exponentially. So for 4 sigma, I'm going to charge you $5 for the meal. For 5 sigma, I'm going to charge you $25 for the meal. For 6 sigma, I'm going to charge you $200 for the meal. Are you willing to put up with 1 bad meal in 20? See what I just did? That, ladies and gentlemen, is what the world needs to understand. So as we discuss that, another example, I'm working with the Coca-Cola bottler in Tijuana, Mexico. All they do is take the Coca-Cola slush that they get from Coca-Cola, mix it with purified water, bottle it, store it in a warehouse, and send it out to the Oxos and the 7-Elevens and whatever in Tijuana and San Diego. And they're installing a new ERP module. And they're not getting the results that they wanted. So I asked them, what's your data integrity of your warehouse? I don't know. I have no idea what the warehouse data integrity is. Let's go find out. So we walked out there and we found out that we would send a forklift truck driver to location 3A to pick up a pallet of Coke Zero. Got it? 3A. And we think that there's a pallet because the data says that there's a pallet of Coke Zero in location 3A. But when the forklift truck driver gets there, what does he or she find? Uh-oh. Now, you're the forklift truck driver. What are you going to do? You're going to go back empty? Because if you go back empty, what's your boss going to say? Or you see there's a pallet of Coke Zero in 3C. Let's go steal that one. Okay? Now I have compounded the data integrity issue, haven't I? Not only was there not one in 3A, but I just stole one from 3C. They found out that their data integrity was 1.5 sigma, less than 50% accurate. How can you drive any algorithm, any decision support system with 1.5 sigma data accuracy? You cannot. And that's what I told them. And now we're better. We hit 3 sigma. 4 sigma's tough, okay? Intel. I mentioned Intel. Tom Caparello, Doug Montgomery, and I, you know Dr. Montgomery? At least you've heard of him. World renowned, okay? Tom and Doug and I did a study at Intel. Not a trivial study. We were asked a simple question. What is the most cost-effective data integrity to drive the ERP decision-making process at Intel? We're spending $1 billion over 10 years to lay in the ERP, SAP, the ERP system. $1 billion. What data integrity do we need? What do you think? I gave you a hint before, okay? The bathtub curve, everything's a bathtub curve, isn't it? The bathtub curve showed up at 4 sigma. Now, what does that tell you? What does that curve tell you? That took a year to figure out, okay? That, ladies and gentlemen, is not a trivial piece of data. How would you go about figuring out what the optimal cost benefit is for data quality related to an ERP system? Got it? Okay. We came up with 4 sigma. At 5 sigma, the cost goes up exponentially. 6 sigma, even further. So that $5 McDonald's became what? 50, became 250. Okay? See? Okay. So, workforce implications. People are our number one asset. You may have heard that. They are not. You don't buy them, you don't sell them, you don't depreciate them. People are the number one differentiator. Okay? People are your number one differentiator. And what we're finding is there are some critical skills that you've got to have today and tomorrow. And I'm going to highlight what those critical skills are based upon the research that we've done over the last 3 to 4 years. Okay? And some of you have work to do. This is surveyed by Gartner. I'm going to skip it. Transformation, this comes out of HBR. Harvard said, we're struggling. If you don't have the talent, you're going to struggle with the implementation of transformative technology. That, ladies and gentlemen, is a dumb comment. I think you would agree. That's a dumb comment, right? If you don't have the horses, you're not going to pull a load. When I'm in Canada, I say, if you don't have the dogs, you're not going to win the Iditarod. But I'm not in Canada. What's that mean? You've got to put people first, focus on the soft skills. I'm going to come back to that. Drive change from the top. Make sure you're acting on the translation of data to information to knowledge. And if you can't fail fast, make sure you succeed slowly. So this is the survey result. You got to have the hard skill set. If you want to pursue Industry 4.0, you got to have the hard skill set, okay? You got to know what I'm talking about. Whether it's machine learning, you're absolutely right, okay? You're absolutely right. Am I talking machine learning? Am I talking digital twins? Am I talking this or that? I got to have that understanding. But I also need the soft skills, the social skills, the cognitive skills. I need to get you to think about becoming a data scientist. If you're an industrial engineer, you need to be a data scientist, industrial engineer. If you're an engineering management major, you need to be a data scientist, engineering major. That's the world we live in. Critical thinking, okay? So that's going to change the game. This is Hilpert's work. Hilpert said, it used to be we'd have some low-skilled workers, a lot of medium-skilled workers, and some high-skilled workers. In tomorrow's world, Hilpert's projecting we're going to have more low-skilled workers, fewer medium skills, and more high skills. Why? That chart is fundamentally different, isn't it? Agree? That's a different chart. Why do I need more low-skilled workers and more high-skilled workers and fewer medium-skilled workers? Why? Come on. Competition? Yep. Come on. Specialization. I'm going to focus, aren't I? But I want you to focus and think about being narrow and broad from a soft skill standpoint at the same time. Come on. You got to speak up, young lady. Medium skills are going to transition, aren't they? Okay? Very astute. Very astute. Nice job. Thank you. Got the chart? Not a trivial chart. Hilpert's work's been recognized, okay? We need to do this. So this is the survey that I conducted in Mexico. We asked 42 business leaders in Mexico, what are your biggest gaps from the engineers that you're hiring? I teach in Mexico a lot, okay? I'm still active in there in Mexico. What are the, look at the top ones in red, okay? Look at the top skills that they're not getting from the engineers, not just from my university, but from Mexican universities. And begin to think about, okay, do I have any gaps in that list? Come on. These are the soft skill gaps. These are the soft skill gaps the industry is telling my university and others in Mexico they're not getting from their graduates, okay? Did I answer your question? Okay, yes ma'am. I'm sorry, I'll come to you.
Because change happens when the money is. So you have to know how to speak money.
Okay, so the observation is change happens where the money is. Agree? I disagree. Okay? And there's a reason for it, okay? Okay? I cannot buy change. I have to have a fundamental understanding, and I can walk you through some work by Pat Zagarmi and others, and I don't know whether I've got it in this talk or not, that talks about what is required to fundamentally make change successful, okay? And if I haven't included it, I'm in the light here. If I haven't included it in this talk, I'll send it to your professor and he can pass it on, okay? I can't buy you to the financial wizards and we have an existence of that today, don't we? Okay. How do you get them to recognize? So I come back to value. Okay. If they see the value in making the change happen, they will embrace it. Okay. I'm giving a workshop at AME in St. Louis in October about, and I'm giving one here at ASU in May about migrating from bottom up to top down. Okay. And how do you get the buy-in at the top down? That's a whole different talk. Okay. And we would be here till 7:30. Okay. So focusing on AI, I'm going to skip this. Okay. Because I want to hit one more topic, and I've been talking too much. How do I move these faster? because there's one thing I want to conclude with, and then I want to save a little time for. This is not the world's fastest computer. Okay. I'm going to change gears now. My premise going in was the following. We've got our beloved friends in computer science doing incredible work in developing AI algorithms, all different types of AI algorithms. There are some real issues in terms of implementing a data based, structured decision support system that uses AI. Okay, that's where we come in as system engineers. And I'd like to conclude this talk by highlighting what I think that means for us. I'm a system engineer. Next week's 50 years being a system engineer. Okay, so I've been at this a little while. Today's issues. And I'm going to use software development as an example, okay? To your point, Goldman Sachs used generative AI auto coding to improve software development by 20%. You think that's worth it? That's pretty good, 20%. Now read the next line, would you please? Okay. A health insurance company enabled a junior developer with no experience to generate an explanation file with 95% accuracy and 54% faster. That's what's scary. I've got individuals being handed a generative AI algorithm to perform a task, and they have no clue what's going on. Could something wrong happen? Could the wrong interpretation be made? Could I send the rocket in the wrong direction? Yes. Okay? And that, ladies and gentlemen, scares the dickens out of me. Without understanding the context, without understanding the broad system engineering concepts, we got trouble, and that scares me, okay? So, software quality. This is a definition that they use. The measure of software product ability to satisfy specific needs, user expectations through attributes such as robustness, reliability, efficiency, simple. You know what? That sounds like systems engineering to me. You've covered system engineering, right? Okay. Our job is to bring a program in on schedule, on budget, and meet the customer requirements. Yes? Please say yes. Okay. Okay. Well, that's what software quality is trying to do as well. And they're trying to use AI algorithms to do that. So the risks are the following, and this is a great quote. The benefit of using generative AI in engineering is that it simplifies something that is highly complex. Somebody said we got real complexity out there. The challenge of using generative AI in engineering is that it simplifies something that's highly complex. Got it? This is not trivial, ladies and gentlemen. That's where you come in. We need abilities. Deloitte highlights these 7 issues. Application design can be opaque. I cannot see what's going on behind me. Multi-agent solution. Code efficiency and accuracy can be hard to balance. If I'm writing efficient code, it may take me longer. I got a yin and yang going on here. Code simplicity, non-standardized inputs. This is where we come in. Development of security operation. Innovation limitation. So, have you heard about DODAF? Ali, have you covered DODAF yet? Okay. Let me introduce you to DODAF, Department of Defense Architectural Framework. What we faced in the Air Force, what we've developed over the last 10 years or so, is what we call an architectural framework, a means by which we can structure a program such that we feel comfortable that we're going to get the outcome that we desire. Okay? In the Air Force, we spend billions of dollars and don't always get what we want. The same is true in industry. So we created something called DODAF, Department of Defense Architectural Framework. And DODAF, this is a real stretch. This doesn't exist. This is where you get to do your dissertation, okay? Please say yes. Okay. This is your dissertation topic. Apply DODAF to artificial intelligence software development. Boom! I just gave you your dissertation. I'll be happy to be on your committee if I live that long. What's DODAF? DODAF looks at the Department of Defense Architectural Firm, looks at it from three perspectives: the operational view, the technical view, and the systems view. Think about it. When I'm putting an AI decision support system together, I need to look at it from an operational view, a technical view, and a systems view. Let's expand that, okay? I'm going to skip that chart. So, when I talk about architectural framework, I'm talking about rules to develop things. So, what's similar between this Gothic cathedral and this little home over here, okay? What's the same? And is there any way that I can use the rules from each of those to build this house? Is there any way that I can do that? The answer is yes. There are rules, aren't there? If I'm going to have, for example, if I need a flange to put something together, don't I? I've got to have something behind it to hold it, don't I? Okay, that's a rule. Whether I'm doing a Gothic cathedral or a 3-bedroom home or a less than 3-bedroom home. Okay, got it? So, DODAF, and I'm going to close probably with this chart, and then we can chatter, okay? Operational view, technical view, systems view. Operational view identifies what needs to be accomplished and who's going to do it. Not trivial. What are the fundamental requirements? What is the minimum essential functionality? That, my friends, is a system engineering phrase, isn't it? Minimum essential functionality that defines the requirements that will meet the customer requirements. That I'm going to call the operational view. Then there's the systems view. Relates to the systems and characteristics to the operational needs. So we're going to link systems to operation. And then finally, there's this technical view. What kind of support systems, what kind of rules, what kind of other standards and conventions should we apply? Now, the operational view tells the systems view what needs to be done. The operational view tells the technical view the operational requirements. The systems view tells the operational view the systems that support it and specifies the systems to the technical view. The technical view says supportability, new technical capabilities, and technical standards. What we need in artificial intelligence is a DODAF-like capability that will allow us to structure a decision support system development using any algorithm that you want, a decision support system algorithm, to fundamentally understand that we are meeting the requirements with the proper technology, with the proper standards, in a logical manner. And there's ways to do that, okay? I'm going to stop. Is that enough? What did you just hear? We've been at it for a while, okay? We solved the technical problem. Thank you. What did you just hear? Come on. You're grad students, you're undergrads. Look at your notes. Come on, thank you. Be data scientists. Interpret that for me. What does that mean to you, sir?
Make sure that you're using AI, fullest capability, but making sure the data integrity is there.
Okay. And I don't want to force fit AI, okay? It's just another tool. Now, if you talk to my grandson, it's way more, Grandpa, than another tool. It's my life, okay? But from a system engineer, AI is just another tool. Reasonable? What else did you hear? Come on, please. I'm sorry. Makes change happen. Lead change. Pat Zagarmi, brilliant lady, put together a nice package. And there are 6 things that Pat says you've got to have in place to make change happen. Number 1, I'm going to try and do this by memory. Number 1, have the individuals that are going to be affected understand what the change means, okay? And don't write a 3-ring binder full of material, write a 1-pager. When I'm doing a big system, I publish a 1-page synopsis. We call it an A3 format. A 1-page synopsis of the entire program and present that to everybody in the organization. Why? Because they have to understand what's the big picture that we're dealing with. Step number 2 then, I have to think about what's in it for me with them. Okay? I have to make it personal. If I make the change, let's say Dan has been working on your factory floor for 10 years. I'm good. But you think that there's a robot that's better than I am. And you're going to replace me with a robot. What am I going to say? How do you get Dan to buy into the design of the robotic system such that she or he, Danielle or Dan, understand that it's a better solution and there's still a job for them? So when I'm doing Kenworth of Mexico 15 years ago, okay, I asked Gustavo Vildoso, who owned the company, to stand up in front of the audience and say 2 things. Number 1, we're going to streamline Kenworth of Mexico, okay? And I asked him to say 2 things. Number 1, I trust this guy. And number 2, no one's going to lose their job by identifying waste within the organization. Okay? So a chart that I skipped, Kenworth of Mexico, published article, journal article. We started out at 8 Kenworth trucks a day. You know what a Kenworth truck is? Big monster, Class 8, over-the-road truck, drives on I-10 and I-17 and I-8. You know what they are, right? Luxury liners these days. When I walked in the door, we were assembling 8 trucks a day. 8. In 18 months, what would be a reasonable target for productivity improvement? Currently, we're making 8 trucks a day. Oh, by the way, we're not going to spend any money on capital, and we're not going to increase the headcount, okay? We're making 8 trucks a day. In 18 months, how many trucks do you think we can get to? 12? 16? Double production in 18 months? That's a lot to ask. Agree? We had 22. But we didn't stop because the audience bought into the notion that this is the right thing to do. So in the next 18 months, we looked outside the 4 walls of the factory, and we went from 22 trucks a day to 42 trucks a day. Now, is that value? Yep. And Gustavo, who owned the company, was making a little bit of money making 8 trucks a day. How much money is he making? Making 42 trucks a day. How much money is he? A lot. A lot. Agree? Come on. What?
So, like, what percent of improvement do you need by AI to theoretically eliminate some?
Okay, so the question is a good question, and I think the jury's still out, okay? Because there are multiple dimensions of improvement that we can talk about, okay? From a timing standpoint, if I can improve the timing, say, by 20%, it probably makes sense, okay? But there are other dimensions. Quality. I have the ability I can't make 3-micron, 4-micron semiconductor chips with these eyes. Neither can you, okay? But that's what TSMC is working on, 3-micron, okay? I have to automate that process, okay? So sometimes I'm just forced into automation. Dev Pillay, my old neighbor down in Chandler, put the Intel automation strategy together when we went from 8-inch wafers to 12-inch wafers, and we were carrying 25 of them in a boat. I could not physically carry that boat, okay? So we had to automate the process. There are lots of dimensions, okay? Got it? Come on, yell at me. To support you on that, I do AI under define, measure, analyze, improve, control. Yes, it does. Yes, it does. But if you read Michael's original book, Six Sigma book, you know Michael Harry? I happen to know Michael. Michael passed away a few years. I had the chance to meet Michael. We were working on the next generation when he passed away. It's not define, measure, analyze, improve, control. There's an upfront strategic element, RD. If you look at page 115 of Michael's original book on Six Sigma, RD, strategically recognize and strategically define what that opportunity is. That gets the leadership involved. That's this young lady's comment, okay? Strategically, what impact is this going to have? Then break it into projects, define, measure, analyze, improve, control. But you don't stop there, because then he says SI at the end. Standardize and integrate, okay? If I don't get to standard work and make the change happen and document it in standard work, I'm going to lose 70% of the gain in the first 2 to 3 months after I make the change. Okay? So it's RD, DMAIC, SI. Now, can AI help me do that? Absolutely. But it's not going to replace me. It's going to help me, at least in my lifetime. I'll let you live that out. Okay? I'll watch. I don't see it replacing. I see it complementing. Okay? But there are certain things that AI can do that's much better than what I can do. Come on. Yeah. Yeah, we're already pushing 5.0. And that's the next generation of AI, okay? Where right now many organizations are calling it 4.5. They're taking it to the next level, okay? And there's already a 5 on the horizon, okay? Hit the literature. Hit the literature. Okay.
Vice versa. Could you give us an example of a catalyzer that would actually help bind the operational view, the technical view, and system view, so that the chart of explosive growth, fast for the combined work of CEs and IEs and SEs.
You got another hour and a half?
That's all I got.
Okay, so any major Department of Defense weapons system will follow DODAF today. So hit the literature, look under DODAF examples, okay? A Google search, an AI Google search, okay? Find out, get some examples there, okay? I can't answer that in the 30 seconds that Ali's given me. Last question. Come on.
In improving data quality, or should invest more in AI algorithms?
Okay, so the question is, should they invest in data quality or should they invest in AI algorithms? Okay, which comes first, the chicken and the egg? okay? And I'm not being facetious here. I have to have the data quality to drive any useful AI algorithm. But I don't know what that data quality needs to look like until I start to spec out what that algorithm is going to look like. So there's a yin and a yang. If I had to vote, I would vote for data quality first, okay? And I'm pushing you. 4 Sigma's tough. Got it? 4 Sigma data warehouse 4 Sigma. A design quality 4 Sigma. Quality at the source manufacturing 4 Sigma. It's tough. Thanks.